Hello friends, welcome to Joy of Life. So today we are going to look at another sorting algorithm, and which is a very common sorting algorithm and widely used is a merge sort, right? So just like quick sort, as we have seen earlier in a video, that merge sort is also a divide and conquer kind of algorithm, but which produces n log n in the worst, best, or in the average case. Unlike the quick sort where we have seen that the worst case is order of n square, here the worst case is also going to be your n log n. So all the cases what you will end up is having a n log n. It's a general purpose sorting algorithm, you can say, which is quite efficient and which is a comparison based mechanism. Once again, we are going to understand it in full details how it works, and we have taken the same array that we have taken for quicksort and we are going to apply merge sort. And what quicksort basically does, it starts dividing the array, right? It will pick up the middle and it will keep on breaking your array. It will keep breaking it until you reach a bottom case wherein you just have only one element, and then it will roll back up again, right? So let's say this is our array over here. So what we know is we have a left and right in array, right? That is initially the starting and the end of the array, right? So let's put some pointers there. So what we are going to basically do is we need to find out the mid. So we are equally partitioning the array, right? So how do we get the mid? So we are basically going to use this formula in order to get the mid. So our starting index is 0 and our end index is 7 over here. So let's put down the index over here for the simplicity of understanding. What we are going to do is we are going to do a 0 by left is 0 plus right is 7 minus 1. 7 minus 1 is a 6. So basically let's put it down over here. 0 plus right is 7 minus 1 by 2, which is just taking the middle, nothing fancy about it. So 0 plus 6, which is a 6 by 2, which is a 3. So our first mid will be a 3, and we are going to partition based of this mid. So we are going to partition based on this position, and we are going to spawn into two recursion again. So one is from left to your mid, the other is from your mid plus 1 to your right. So we'll end up having these two recursion in place, right? So this is the two trees coming out of it, right? Now what will happen, we are going to calculate the mid all over again, and we are going to do it with 4 and 7, right? For this tree over here. So if I take the left at 4 and 7, which is my right. So what will happen is 7 minus 1 is a 6. 4 plus 6 is a 10. 10 by 2 will have a mid at 5. And once again for this subtree, what it will be is 0 plus 3 minus 1 by 2. So 3 minus 1 is a 2. 2 by 2 is a 1. So we'll be putting at the first index. So we'll have the mid around this point. So we'll again spawn out two trees. We'll partition based on the mid and we'll break it up. So from this part, these two, left to mid is one tree. Mid plus 1 to right is another part of the tree. Again over here, left to mid is one part of the tree, and mid plus 1 to the right is another part of the tree. And in this case, what will happen is all the left will become the mid, right? Because there are only two elements. So the next level will have only one element each. So let's see how that will look. I'm not putting the mid for this level. I hope you got it. So now what will happen is we'll have one element each, right? So as you can see, the left, right, and mid all has become one now. So eventually your tree will look something like this, right? We have split until we reach a case wherein the left and right is now at the same position, right? Because we have only one element here, right? So before we do any further thing, let's understand few things over here. So this operation that we are seeing over here, this part of the operation will cost me log n, right? Because every time we are doing a half. So this can be achieved in log n time, right? And what would be the pseudocode for the same? So if left is less than right, that means the left and right is not pointing to the same element, right? There must be two elements. That's why left and right is not on top of each other, right? And in that case, what we are going to do is we are going to call this merge sort function again. And what are we going to call it with? We are going to call it with array, the left side, and we are going to take till the mid, so that the mid becomes the right next time, right? And also the subsequent function that we are going to call is for the other half, that is with the mid plus 1. And this will give me this kind of a structure that we want to, right? So when left and right, so in this case what will happen, left and right will both become same. In that case we are no more going for a merge or split of the array, right? So this is where we will be stopping, where left and right points to the same pointer. So all in these nodes everywhere you see there are only one element, so left and right are definitely pointing to the same element, right? Now we have nothing more to do. So now what we'll start doing is we'll call our merge function. So now every element is a single element as we have split it down, right? Now we have to merge them back, and while merging them back we are going to perform the sorting over here, right? So we are going to call this merge function, and what we are going to pass is we are going to pass the array, the left, the mid and the right. So for every recursion we know the middle point, right? And we are going to pass that middle point, and we are going to pass the right as well, right? So for this level over here, nothing is going to happen. It is going to remain as is, right? Because the left, right and mid that we are passing is all at the same index, 0 or 1 or 2 or 3 or whatever, right? Now what will happen is we'll go to the next level, right? When we go to the next level, what we get is a left which is at 0, a right which is at 1, and a mid which is at left, right? Over here we did not put the mid, but mid was at left. So what we are going to do is at this level, when we are going to pick up things back, we are going to sort them. And how we are going to sort them is basically what we can do. There are many ways you can do it in place also, or you create two arrays over here. Copy the left till mid, that is one element, and mid plus 1 till right into an array, and then merge them back into a single array. What will checking that whatever is smaller should be coming first. So the basic intention will go on a deeper level to understand how we'll perform. So basically what will happen at this is we have two arrays. One is having 6, one is having 3. So we are going to continuously see which one has a smaller element on the top, and we are going to take the element back. So while taking things back, we are just going to do a sort. So 6 and 3 will become 3 and 6, 1 and 2 will remain 1 and 2, 8 and 4 will become 4 and 8, 7 and 5 will become 5 and 7, right? And now again we are going to merge them here and appoint a j over here, and see whatever is smaller we take them and increment. So in this case j was smaller, right? So we'll increment from j here to here, and then we check again that who's smaller, right? We'll see that j is still smaller, so we copy j, and then we take, then there is nothing on the j's index, so we'll be taking from I. So we'll take 3 6. So 1 2 3 6 will become my next set of elements. So I will merge them back, and it will look something like this. So you can see that at every level, when we are rolling things back again, we are getting them in a sorted order. So 1 2 3 6 is sorted, 4 5 7 8 is sorted, and again we will do the same kind of thing in order to get the thing sorted up. So we will point a pointer at I, and we'll point a pointer at j, and whatever is smaller we are going to pick that value. So we'll first take I because I is pointing to something smaller, then we'll increment I because we have consumed this value, j remains at its place. So again I see that I is smaller, so I take the 2. So again I increment I still see that I is at smaller index, so I consume the value, and then I increment I, and I see that this time j is smaller, so we take the 4, and then we increment the j. And again j is still smaller than I, so we take 5, and this time what we see, and then we increment j, and this time we see that I is smaller, so what we do is we take the value from I, and I goes past the desired index over here, so I will come over here. So we take the remaining values from j, so 7 and 8 comes here. So this becomes your merged thing, right? So that's what is going to happen here as well. We will end up having this activity again, and we'll be having a merged result at the end, right? So it will look something like this as you see on the screen. So 1 2 3 4 5 6 7 8, it's sorted. Again this is going to cost you a login work, that the same login work that you did. So again, log n and 2 times log n is going to be log n only. Okay, so how we are getting the n log n, right? So over here in the upper half, so this is our half, right? So in the upper half, what we did was we just split it, right? So the amount of time it took is order of 1 doing so, right? Because splitting does not cost me anything, just we have to calculate the mid. So these operations were order of 1. But these operations over here, merging, keeping 2 pointers I and j in both the arrays and getting things done. So this costed me around, so this costed me order of n, right? We are going over all the n elements, right? For first log n elements, we are having a log n into order of 1. So order of log n into order of 1. So which will eventually become log n only, right? And for the second half, what will happen is order of log n into order of n. For each element we did, right? The checking, right? For all 8 elements, we did a comparison, right? So this will result into a n log n. And this will result to a log n, right? So if you do a log n plus n log n, what we eventually get is a n log n, right? It's not going to have any impact. So this is how the entire tree looks, and this is how we are getting a n log n performance on a merge sort. So this is all about the merge sort, but before we end this video, what I quickly like to show you is the code from Geeks for Geeks and discuss them in little detail so that you understand. So we are just going to go over this merging part and we are going to check it out quickly. So here is the merge function. You can see that we did exactly the same thing. So what we basically did is we get the left, mid and the right, and we constructed 2 temporary arrays where we copied all the values first, right? And then we had 2 pointers I and j, which is pointing to the 0th element of both, right? Of the L array and the R array, right? And then we are just putting them back into our actual array, right? So we are putting at the k index, and if I is there, we are taking, and otherwise what we did was we copied the remaining values, right? So this is the loop for copying the remaining values. So if you remember what happened here was when I reached 6, 7, 8 was our remaining values. So we just used the loop in order to copy them back. So this is exactly the same thing that they're doing. If there are any, then we are going to just take them up, right? So yeah, this is all about your merge sort over here. Do let me know what do you think of this video. If you think this video was helpful, do give it a like, share with your friends as well. I try to keep it as detailed as possible so that you understand in all the possible details. I hope I was able to stand up to your expectation at some level at least. So yeah, please do comment and please do share as well to support the channel. If you really want me to create more videos, that's the only that's the only takeaway for me from these videos is the words of encouragement that you are liking the videos and you are really enjoying and learning from it. So yeah, that's all from this video, and once again, stay safe, stay home. The cases are rising badly in India and it's something to really worry. It's almost 23,000 cases every day in Bangalore, just in Bangalore, not even Karnataka. So please do stay safe and take care of your family members, and yeah, that's all. So see you guys, and happy coding. Bye bye.